This is the AB 91 to 94 review. Calculators are not allowed. And it's number 1. All 3 of these involve separation of variables to solve a differential equation. So your goal is to move as little as possible over to the y side because we're eventually going to have to isolate the y when we're done. So if I look at this first one, I can see that I can move the y cubed over to the other side. And I'll leave the 1/3 and the x squared on the right with the dx. So the antiderivative will be y to the 4th over 4 plus a random constant, but we're going to move that random constant to the other side and absorb it in with the random constant from the x side. So we'll end up just having one random constant on the right. Now that we've had or found the antiderivatives, we're at a crossroads. We can either continue on our way and isolate the y, or we can plug in the point. So what I like to do is just test the point initially and see if it'll make it complicated to find the c. I can see that the y is a 2, which will end up getting rid of the fraction, and the x is a 3, which will also end up getting rid of the fraction. So I'm going to choose to just plug it in right now. If I plug in a 2, I have a 16 over 4 is a 4. On the other side, I'll have a 27 over 9, which is a 3. So I end up with a c that is 1. Once I know the c, I go back and plug it in. And then I isolate the y. So to isolate the y, I would multiply both sides by 4. And then I would take the 4th root. Now because the 4 is an even number, when I take the root I have to do a plus or minus. And because I have a plus or minus, that's not a function, so I need to nail down which branch is involved with this problem. So going back to the point, I can see that when I plug in an x coordinate of 3, I should get a positive output or a positive y coordinate. So in this case, I will do the positive root. And I'm done. If I look at part B now, again I need to isolate the variables, or not isolate, separate. So I will have a y on top, and on the other side that 1 plus x squared will remain on the bottom. So antiderivative gives me a y squared over a 2. This will give me a tangent inverse plus some constant. Now again, I can isolate my y, or I can plug in my point now. So plugging in my point now, I have to ask whether or not it's easy to get a tangent inverse of 1. And it is, and it's easy to square that number. So I'm going to square the root pi, or the negative root pi I should say. That'll give me a pi over a 2. And then my tangent inverse of 1, that says what did I take the tangent of that gave me a 1? And the answer to that question is a pi over 4. So I can solve for c and get a pi over 2 minus a pi over 4, which is a pi over 4. So back to this piece, which is where I plug the point in, I'll have a y squared over 2 equals a tangent inverse of x plus a pi over 4. So if I isolate that pi over 4, or excuse me, the y, I will multiply by 2. And then I will take the square root. Square root would enable me to have a plus or a minus, so I have to pick the one that actually gives me the minus because my output is a negative. So I'll get a negative 2 tangent inverse of x plus a pi over 2. Last part, c. Again, I isolate my variable, or separate my variables, pull as little over as possible. So I have a y dy. I leave the negative 1/3 over with the x squared. Integrate both sides. Add the constant on the right only. I can plug in the point now because I'll be squaring a 2 dividing by 2. cubing a 3, dividing by 3's. So I'll get a 2 equals a negative 3 plus c. So my c is a 5. Come back to the point where I plugged in the point. And isolate the y. So I multiply both sides by 2. Take the square root, and I have to choose the branch that gives me a negative output. So that would be the negative root. And I'm done.